Good afternoon. We are team Binky and Brain. My name is Mohamed Hassan. And in this video, we are going to show you how we implemented our smart car autonomous system. I basically contributed in building the hardware of our project, which consists of two Arduinos. The first Arduino used to control the car from the store to the site, and the second Arduino used to control the LCD to show the status of our car. And in this video I will show you in details the components of our project, the components of the car, and the Arduino of the car, and the Arduino controlling the LCD and the IR sensors.
And now I'm going to show you an overview of the hardware of our project. First, the first controller, the first Arduino, is used to display the status of our car. The second controller is attached in our car. It used to control our car from the store to site. And this is the track where the car will move through in the black line from the store to the site. Here in the first controller, which displays the status of our car, it is connected to two IR sensors, one in the store and one in the site. It displays in the LCD whether it's in the store, or it's moving from the store to the site, or from the site to store, or whatever it reaches the site. And now I'm going to show you, I will talk in detail about the second controller, which controls the cars and the component in it. The first component is the first button here. It is the button used to make the car in the on mode or in the off mode. This LED here, the green LED, is used to show that the car is on, and the red LED beside it shows that the car in the off mode. We have here a second button. The second button is used to give a go command from the store to the site, and vice versa. The third component here is the IR sensor, which detects the object, which detects whether there is an object on the car or not from the store. The fourth component is the buzzer. The buzzer will give us a warning when we press the go button and we didn't put an object in the store, and while it's in the store, to the IR sensor. And it will also give us a warning if the car is in the site and we pressed the go button and we didn't remove the product from the IR sensor. Now we have the H bridge, which controls the DC motors, from which it gets its input signals from the Arduino, and the H bridge gets its ampere from the green battery, and the Arduino gets its 9 volt voltage from this battery, which gives the power to Arduino. The line sensor, and here we have the line tracker, which makes the car move in its phase in the black line from the store to the site. And now we are going to put our project into motion. The car now is in the off mode because the LED is showing a red light because the car is in the off mode. Even if I press the go button, it will not give me a warning signal from the buzzer, a warning sound from the buzzer, because it's already in the off mode. Even if I put the product on the IR sensor, it will not go because it's already on the off mode. Now let's put it. First, the car, the LCD is showing that the car is in the store through the IR sensor in front of it, which is detecting the car is in front of it. Now let's put our car into on mode by pressing the first button. The LED, the green LED will light up, showing that the car is in the on mode. Now if we press the go button, the buzzer will give us a sound due to there is no object or product into the IR sensor. Now we will put our object into the IR sensor to move the object, to move the product from the store to the site through the go button. And it's showing in the LCD now that the store, it's in the LCD is in the store to site. Now, in just case the product is failing of the product of the car, the car will stop. And even if we press the go button, it will show us the buzzer. Now let's put the product again in the IR sensor and press the go button to continue its journey. Now it reached our site. The LCD is showing that the car is in the site. And now, if we press the go button while the car is in the site, it will give us the sound of the buzzer, because we didn't remove the object or the product from the car. Now let's remove our product from our car and make the car continue its journey back from the site to the store. And if I push the go button, the LCD will show that the status of the car is going to be from the site to the store. And now we'll press the go button to continue its journey. And the LCD is showing that it's showing the status of the car is from the site to the store. And the car is back in its journey. And now the car reached the store. And now my partner Aley is going to show you the software implemented in our project.
Hello everyone, my name is elAdawy from Team Pink and Brain. I was responsible for the software implementation in the Smart Car Autonomous System project, and now I'll be walking you through the Arduino code.
Okay, so since we're using two Arduino boards to interface with the various components we have in the project, we have two codes for each Arduino. For the first one that we're using to interface with the LCD and the proximity sensors that are stationed at the store and site locations. Here we're including the liquid crystal library so that we can use interface with the LCD. And then we're assigning some pins to the LCD to be able to print to it later on. The X3 variable acts sort of like a state variable, since we have four states for the car, stationed at the store, stationed at the site, and moving from the store to the site, and from the site to the store. And then we're starting off the LCD. 16 and 2 are the numbers of columns and rows that we will be using from the LCD. This is it for the setup. And now moving on to the loop method. We start off by setting the cursor of the LCD, which it sets where the words that we're gonna write appear on the LCD. And then we start checking for the IR. This is where the actual logic is for our project. Pin 8 is designated for the IR sensor that's placed on the store location, and pin 9 is for the IR sensor at the site location. If both are low, So this means that if the store IR is low and the site IR is high, this means that the car is at store. So we print car in store, and then we set the x3 variable to 1. If both are high, this means that the car is moving. But if it's x3, if x3 is 0, this means that we just started, so it just prints welcome. If x3 is 1, this means, or 2, this means that the car is moving from either store or site. So we print the path that the car is moving to. If the site IR is low and the other one is high, this means that the car is currently stationed at site. And then we set the x3 variable to 2. Okay, so now we're moving on to the Arduino that's interfacing with the car itself. First off, we're gonna start with the variables. X1 is for storing the on-off button state. Mode is for deciding whether the car is on or off. X2 decides whether the car is at the site or at the store. Enable the variables with A's are for the A motor, which is the right motor. The variables with B are for the left motor, the B motor or the left motor. Enable just gives an enable signal to the motor. Both pins 1 and 2, either A or B, decide the polarity of the motor. So it tells the motor to move forward or backward. We're gonna jump to the motor controls first before delving into the logic. Okay, so here, this is the functions that are the low level functions that are interfacing with the motor directly. For example, motor A on. It gives a high signal to the enable A pin, so it turns on the motor. Same with the motor B on. Motor A off is the opposite. Same with the motor B off. A forward, for example, it gives a high signal to A1 and a low signal to A2. So this allows the motor to move forward. Let's take motor B backwards, for example. It writes a low signal to B1 and a high signal to B2, so it allows the motor so it's the opposite polarity, so it allows the motor to move backwards. Brake just gives low signals to both pins. So these are the low level functions. Now we can bundle them together to create more usable methods for us to use in the logic of the code to allow the motor to move forward for X amount of time, or turn left or turn right, etc. So enable motors enables both motors. Disable motors does the opposite of that. Backward, for example, moves both motors to the back with an amount of time, a delay. Turn left moves the A motor backwards and the B motor backwards, so we're turning left. You can picture the movement. Turn right, the same. Brake just gives a low signal to all the pins of the motors. Okay, now we are gonna move on to the logic of the code. Okay, so now we're in the setup step. In the setup function, we're setting up the pins, the input and output pins for our Arduino board. The third IR sensor that's on the Arduino, it decides whether the car is loaded or unloaded. The on-off button, the go button, the on-off LEDs, and the buzzer. These pins are for the motor, as we already discussed. Okay, so now onto the logic of the program in the loop method. We start off by detecting the on-off button. If it's high, we delay to avoid the bouncing, and then we add 1 to the x1 variable, which detects how many times you've already pressed this button. And then we check if it's 1. This means that we're going to the on mode. We turn on the green LED and we turn off the red LED, and we set the on mode to 1. If otherwise, we turn off the green LED and we turn on the red LED, and we set the mode to off. Now we check if we're in the on mode. We check if we are at store. X2 = 0 means that we're at the store. And then we check the IR sensor on the car. If it's low, that means that it detects something. That means that the car is loaded. We check the go button. If it's pressed, we delay, and then we enable the motors. If it's unloaded, and the go button is pressed, we fire the buzzer. And then here we check if the car, same thing, if the car is at the site, we do the same thing, except that it's the other way around. If the car is unloaded, we allow it to move. If it's not, we fire the buzzer. Now here's the part where we do the logic for the line trackers. Let's start from here. If both trackers are detecting white, this means that we should move forward. So we call the forward and brake methods. If both are detecting low, that means that we arrived at location. We increment the location variable, which is x2. If x2 = 2, we assign it to 0. That means that we are back at the store. And if it's if the left one is seeing white and the right one is seeing black, we should rotate right. So we brake first and then we turn right. Otherwise, we brake and we turn left. At the end, when the car is arrived at the store, we turn left. We rotate left, and then we brake and disable the motors. And this means that the mission was accomplished successfully. Thank you.